in various values of x's and then try solving. So first you're going to do random values. So you're going to go f of 0, plug 0 in for all the x's.
Then the shape of the graph is always like this. It's always going to be, so it's going to be exponentially growing. If a is negative, however, it's just the other way around. And you guys know this because you guys are C1, right? Transformational graphs.
And I'm going to cover binomial expansion after that. So first of all, we're going to look at finding the common ratio. Then we look at calculating the nth term, finding some of geometric sequences, solving problems with growth and decay. And this part is not examined in Edexcel, but it does come up in other boards, okay? So there's one thing called periodicity. And that is when you sequence, it alternates, okay? So what do you think, jamming molecules? Do you think to have high boiling point, low boiling point? Right, yeah. So ice, when it's liquid, it takes up a lot less volume than when it freezes. Yeah, because when it freezes, the hydrogen bonds make it expand into this tetrahedral structure. Yeah. So you have the instantaneous / temporary dipole here. What happens is this delta negative, because the electrons are here, it will repel the electrons on the next atom, on the next molecule. Yeah? So obviously these are both negative.
Overall intermolecular force is stronger for that. Does that make sense?
So this is high in energy. And this is lower.
That's the main difference that you need to know between these two kind of steps. When you have two radicals making a stable molecule, that's the termination step. And when it's a radical with a stable molecule making a different radical and stable molecule, that's your propagation step. Does that make sense? If you had an alkene like this and you didn't know that it was an alkene, how could you use this as a test to check whether you had the alkenes and the bromine, right? What would bromine do to this? Decolorize it. Why? Why is it decolorize when you add bromine?
Because the double bond opens up.
Exactly. The double bond opens up exactly in that way there by electrical condition.
That's right. A greater proportion because the area, to the right of that, i.e. of those particles which have sufficient energy, greater than the activation energy, is greater. So you get a greater proportion of successful collisions. And that's really it. It will encounter another sort of negatively charged area which won't be favourable because there'll be a lot of repulsion. So there's only really one direction that a nucleophile can attack in this SN2 way of nucleophilic substitution. And as a result, out of all the collisions that take place, only a certain proportion of them will have the reactants colliding in the right direction, in the right orientation, more specifically.